From the volcanic plumes of Io to the icy crust of Europa, the moons in our solar system are as varied and intriguing as the planets they orbit. Often overlooked in favor of the gas giants or the mysterious outer planets, these natural satellites hold secrets of their own, some of which may even unlock the mysteries of life beyond Earth. In this episode for the Sky Grids, we will take a journey through the moons of our solar system, exploring their unique features, histories, and the crucial roles they play in shaping the environment of their home planets. The inner moons, Earth's familiar neighbor and Mars' two sentries. We begin our journey with the celestial body most familiar to us, our moon. Orbiting Earth at an average distance of 384,400 kilometers, the moon has been a companion to our planet for billions of years. It influences Earth's tides, stabilizes its axial tilt, and has served as a beacon for human exploration. From ancient myths to modern science, the moon has played a central role in human culture, yet its origins are still debated, with the giant impact hypothesis being the most widely accepted theory. The moon's heavily cratered surface tells a story of its violent past, while its basaltic plains, known as Maria, hint at ancient volcanic activity. Despite its seemingly barren landscape, the discovery of water ice in the moon's shadowed craters has reignited interest in using it as a potential base for future space missions. Mars, the red planet, is orbited by two small, irregularly shaped moons, Phobos and Deimos. These diminutive satellites are thought to be captured asteroids from the nearby asteroid belt, a theory supported by their composition and irregular shapes. Phobos, the larger of the two, is slowly spiraling inward toward Mars and is expected to either crash into the planet or break apart in the distant future, forming a ring. Deimos, meanwhile, is slowly drifting away from Mars. Although these moons lack the geological activity or atmospheres seen elsewhere in the solar system, they offer key insights into the dynamics of small moons and the history of asteroid capture events. The moons of the gas giants' diversity beyond imagination, Io and Europa, Jupiter. The largest planet in the solar system, Jupiter, is orbited by an impressive 95 moons, but none are more captivating than the Galilean moons Io, Europa, Ganymede, and Callisto, all discovered by Galileo Galilei in 1610. Io, the innermost Galilean moon, is the most volcanically active body in the solar system. Its surface is a chaotic landscape of lava flows, sulfur deposits, and constantly shifting crust. Io's intense volcanic activity is driven by the gravitational forces of Jupiter, which cause immense tidal heating within its interior. Europa, by contrast, is an icy world with a smooth surface of frozen water hiding a vast ocean beneath. Scientists believe that this subsurface ocean, heated by Europa's own tidal forces, could harbor the conditions necessary for life. Recent missions, such as NASA's Europa Clipper, aim to investigate this possibility further, making Europa one of the most promising candidates for finding extraterrestrial life. Titan and Enceladus, Saturn. Saturn is home to Titan, the second largest moon in the solar system and the only one with a dense atmosphere. Titan's thick, nitrogen-rich atmosphere and liquid methane lakes make it a world unlike any other in the solar system. Beneath its hazy atmosphere, Titan's surface is shaped by rivers, lakes, and seas of liquid methane and ethane. It's a frigid world, yet its complex chemistry and organic compounds have long intrigued astrobiologists. Then there is Enceladus, a smaller but equally fascinating moon of Saturn. Enceladus's surface is covered in ice, but beneath this icy shell lies a global ocean. Geysers near the moon's south pole regularly eject plumes of water vapor into space, hinting at hydrothermal activity deep within the ocean. Like Europa, Enceladus is considered a potential home for microbial life, and missions like the Cassini spacecraft have provided tantalizing glimpses into its inner workings. Ganymede, the largest moon in the solar system, is bigger than the planet Mercury and has its own magnetic field, the only moon known to possess one. Its icy surface is crisscrossed by a mix of old cratered terrain and younger grooved regions, suggesting a complex geological history. Scientists believe that Ganymede also harbors a subsurface ocean, adding to the intrigue surrounding Jupiter's moons. Callisto, Jupiter's outermost Galilean moon, is one of the most heavily cratered objects in the solar system. Its ancient surface has remained largely unchanged for billions of years, offering a glimpse into the solar system's early history. Despite its battered appearance, Callisto is thought to contain a subsurface ocean, making it another candidate for future exploration. The icy moons of Uranus and Neptune, cold and mysterious worlds. The ice giant Uranus is orbited by 27 moons, with Miranda, Ariel, Umbriel, Titania and Oberon being the largest and most notable. These moons are icy and heavily cratered, with Miranda standing out for its bizarre surface features, including massive cliffs and fractures. Miranda's unique landscape has puzzled scientists as its geological activity seems disproportionate to its small size. These moons are distant and cold, receiving very little sunlight, yet their varied terrains suggest that some form of internal heating may have shaped their surfaces. Uranus's moons, much like the planet itself, remain relatively unexplored, leaving many questions about their origins and composition unanswered. Triton, the largest moon of Neptune, is a world with a fascinating backstory. It is thought to be a captured Kuiper Belt object, which explains its retrograde orbit around the planet. Triton's surface is covered in nitrogen ice, and like Enceladus, it has active geysers that spew material into space. This suggests that Triton may also have an internal ocean beneath its frozen crust. Triton is unique among large moons for its icy volcanic activity known as cryovolcanism, which indicates that the moon's interior is warmer than its frigid surface might suggest. Its retrograde orbit and unusual characteristics make it one of the most intriguing objects in the outer solar system. While Pluto is no longer classified as a planet, it and other dwarf planets like Haumea and Eris have their own moons. Charon, Pluto's largest moon, is so massive relative to Pluto that the two form a binary system, with both bodies orbiting a point in space between them. Charon's surface is covered in water ice, and scientists believe that its formation was the result of a massive impact early in Pluto's history. Other dwarf planets in the Kuiper Belt also have moons, many of which are still being studied as new data from missions like New Horizons becomes available. These moons, though small and distant, play a key role in understanding the early solar system's formation and the processes that shape the outer reaches of the solar neighborhood. The moons of our solar system are as diverse as the planets themselves. From the volcanic fury of Io to the icy life-bearing potential of Europa and Enceladus, these celestial bodies offer a glimpse into the dynamic forces shaping our solar system. Moons are not mere satellites, they are worlds in their own right, with their own stories to tell. As space exploration continues, the moons of our solar system may become the next frontier in the search for life, resources, and the origins of planetary systems. Whether through robotic missions or someday human exploration, these moons will continue to captivate scientists and stargazers alike, reminding us of the vast and varied nature of the universe. In the end, the moons of our solar system are more than just companions to the planets. They are guardians, storytellers, and perhaps even the keys to our future in space. Subscribe for more.